Hello everyone, welcome to another Python video. This time we're going to be solving the triangle times problem from the CCC 2014 Junior 1 question. Alright, the question reads as follows. You have a trouble remembering which type of triangle is which, so you write a program to help. Your program reads three angles in degrees. If all three angles are 60, we output equilateral. If angles add up to 180, exactly two of the angles are the same, then we output isosceles. If all three angles are 180, but no two angles are the same, then we're going to output scalene. But if the angles do not output or add up to 180, we're going to output an error. In this question here, we're going to start off with three inputs. And we're just going to do this normally as possible. Since we're getting angles, I'm going to have angle 1 set to, at this point, let's assume that we're going to get integer variables. So we're going to go input, enter angle 1, and end that bracket. I'm going to be copying this over two more times to get angle 2 and angle 3. All right. When I read this problem, one interesting condition that I see right away is this portion here. If the three angles do not add up to 180, we're going to output error. I want to do that first so that I'm not adding up values and whatnot, or considering the possibility of having an equilateral, isosceles, or scalene if I have an impossible triangle. Because if I already know that if I have an impossible triangle, I'm not going to do any of the processing to calculate whether if it's an equilateral, isosceles, or scalene triangle. All right, so what we're going to do is we're going to have an angle sum. Here we can easily write angle 1 plus angle 2 plus angle 3, but what you could also do is something like, you can say that the angle sum is equal to a list of angle 1, angle 2, and angle 3, and then you can put that in a sum function. And what the sum function does, it adds up all the items' values all together and gives you a single integer or a flow. But in this case, the calculations are simple enough. We only have three values, so this is perfectly valid. I just wanted to show you how to use the sum function. Okay, so the first condition that I want to check is if angle sum does not equal 180. If so, our output is just error. So we're going to output error. Otherwise, we have a potential triangle. So we can assume we have a valid triangle. Okay. So now we just have to check for these three conditions, and then we can end our program. I want to talk about this one here. If all three angles are 60, okay? If we know that the angle sum is all 180, that means that for all of our angles has to be the same, as in all the angles has to be 60 for an equilateral triangle. There's a really nice, easy way to write this in Python. It's called a chaining of comparison operators. So we can write if angle 1 is equal to angle 2 equal to angle 3. Now, this is chaining the comparison operator of double equal sign. And I'm just going to go into my Python interpreter here on my terminal and show you how this works. So let's say, for example, I had 10 is equivalent to 11. That's going to be give me false. If I do 10 equivalent to 10, that's going to give me true. Now, in most languages, you're going to have to write that if 10 is equal to 10, and 10 is equal to 10, and 10 is equal to 10 in a scenario where we're looking at angle 1, angle 2, and angle 3. So that's a little confusing. So let's do A is equal to 10, B is equal to 10, and C is equal to 10. So in a scenario like this, we would have to say A is equal to B, and A is equal to C, and B is equal to C. For us to properly compare A with B and A with C and B with C and so forth, making sure all the angles are all equivalent to each other. And it will be true. But for us to really condense that down in Python, Python allows this act of chaining the equality operator for the comparison operator, so that we can compare all three values at once, that they share the same value. And in this case, it is true. So if I were to say that C was 11 and try to run A is equal to B equals to C again, it'll be false because one of the values is not 10. Right? So we're going to take this learning concept and bring it over to our question, because this is really simple to write. I can say that angle 1 and angle 2 and angle 3 are all different. All equal to each other. So therefore, we have a nice equilateral triangle. So I can say print. We're going to output equilateral. All right. I write an elif here because I don't want to write an if, because if this was true, there's no other triangles that we can create from this. Therefore, I just want to write a little elif saying that, well, if this wasn't true, there's another condition I want to check. Okay, if this is true, I don't need to consider the conditions of all my elif statements and else statements below this. Therefore, another condition I can check is angle 1 doesn't equal angle 2. Now I'm going to check for my scalene. I'm going to write the check for this question here so that I can determine if it's not an equilateral, and if it's not a scalene, I can have the isosceles left over. So I'm going to say if angle 1 doesn't equal to angle 2, and angle 2 doesn't equal to angle 3, and that angle 1 doesn't equal to angle 3 as well, like that. I'm just making sure I spelled everything properly. Good. So we checked that angle 1 and angle 2 are not the same. And we checked also that angle 2 and angle 3 are not the same. And we made sure that angle 1 and angle 3 are not the same. Therefore, we've checked them all. And if they're not all equal, we can output print. We have an scalene triangle. So we're just going to put that right here. And we're going to print scalene. Then I can say all else. If this was false and if this was false, we know for sure we have a proper triangle, but it's going to be an isosceles triangle where at least two of the sides are equal to each other. All right. Now, the reason I did it this way is because I want to show you how the AND operator works. So if you're using either an AND or an OR logical operator, what it does is it doesn't mean the English sense of AND, where you have this and this and this and this of this, but rather we're saying if this is true and this entire statement is true and this entire statement is true, as in we only evaluate the Boolean value of the left and the right side of AND. It's not a keyword that combines multiple things. Okay, and a lot of beginner programmers will get that. Will make a mistake by using the AND operator. Okay. I just wanted to show you that there has to be a Boolean-based expression on the left and the right side of AND always. Okay, and as long as all the statements on the AND statements are true, then we'll be able to get the scalene output. All right, so we can try a basic. Well, let's try this program out. So we can say vid 12.pi. Right, we can do 60, 60, 60, and we have an equilateral triangle. But if I were to say 30, 60, and 90, we have a scalene triangle. And if we were to do something like 50, 50, 80, we'll have an isosceles triangle. But if we make an impossible triangle like 10, 20, 30, we get an error. All right, so this was just a quick video on determining the type of a triangle based on the angles given. We were given 3 angles. One thing I wanted to talk about was the sum function, that if you have values in a list or a tuple, we can use the sum function to add up all the values in such collection. We can also, sometimes we want to do a condition right away so that we can guarantee that we can use an else statement where we can have some guarantees about the next section that we can write our logic about. So that's a nice little programming tidbit there. We learned about chaining comparison operators, where instead of writing something like this, where you have the and between the and like that, we can make a statement such that angle 1 doesn't equal angle 2, and they all doesn't work equal to each other, like so. Where they all equal to each other like that. Now, personally, I think we can't do that with the not equal to, because I don't know if it's chainable. I'll have to do some testings, and if I do find out, I'll let you know. Anyways, thank you for watching, and stay classy.